This is problem 7-60 from section 7.1.4 homework. Rip-Off Rentals charges $25 per day plus 50 cents per mile to rent a mid-sized car. Your teacher, me, will rent you his or her family sedan and charge you only 3 cents if you drive 1 mile, 6 cents if you drive 2 miles, 12 cents if you drive 3, 24 cents for 4, and so on. Part A says write an equation that will give you the cost to rent each car. So an equation for the rip-off rentals and an equation for your teacher's car. So let's just compare the two equations first. This rip-off rentals, they are giving me a flat rate of $25 per day plus an additional charge of a constant 25 or 50 cents for every mile I go. So this one is going to be linear. Okay, so we can figure that out. So we have y equals, now we kind of have two different variables going on. We have money per day and money per mile. So I'm going to say it's kind of a startup price of $25 per day. So we're going to call that D. If I was only going 1 day, it would be $25 plus however many miles I ended up traveling. So they're charging you for two things. One, just for having the car for so many days, and the second thing they're charging you for is the distance that you're traveling. So $25 times however many days you're gone, plus 50 cents every mile you go. So we'll call that 25 or 0.50 m for the miles. Okay, so that's rip-off rentals. Now, your teacher charging you 3 cents for 1 mile, then only 6 cents, then 12, then 24. If we think about this, is it adding the same number every time? 3 to 6 to 12 to 24. It's not adding the same thing every time. It's kind of multiplying by something every time. Okay? And also we notice in the teacher situation, they're only charging you for the miles, so I'm not going to have a variable for D in the teacher equation. Okay? So here we're talking about it's kind of multiplying every time. So let's think, what's the starting price? The starting price for driving 1 mile, they're going to charge you, I'm going to charge you 3 cents for 1 mile. So what we're going to write is 0.03 is our starting price. What's happening? We said it wasn't adding the same number every time, but it's kind of doubling your numbers. It's doubling the price. So I'm going to have a multiplier of 2 every time. Okay, it's doubling my price. But so let's have my miles up here, and let's check if that works. So if I go 1 mile, so if I type in 0.03 times 2 to the first power. This is just for 1 mile. It's supposed to be 3 cents. Now that does not give me 3 cents. This would give me 6 cents. Okay, so my exponent is now just going to be the miles. So to make this work, for 1 mile it would just have to be 3 cents. So we would need to make this go away. So I need to make this exponent, instead of being a 1, if I make this become a 0, anything to the 0 power is 1, so I'd be at my 3 cents. So that would be good. So what can I do? How did I go? I had a 1 up here and I got to a 0. I'm going to take away 1. So let's see if that works, if that's better than just having my exponent be the number of miles. So let's say 0.03 times 2 to the, let's say we go 2 miles. So it would really be 2 minus 1. Does that give me 6 cents? That would be 0.03 times 2 to the first. Yes, it's going to give me 6 cents. So my exponent is really going to be number of miles minus 1. Okay, so those are my two equations. The first one for the rip-off rentals is linear. The teacher one is multiplying every time. It's a multiplier of 2, and you started at originally 3 cents. Okay, so now I'm going to use those equations to answer the next questions in part B. If you plan to rent a car for a 2-day trip, that's one of my variables, which is a better deal if you drive 10 miles versus doing 2 days and 20 miles, 2 days and 100 miles. So we're going to compare which one would you rather rent from, which is the better deal. So let's talk about 2 days and 10 miles. So what we're going to do is plug those numbers into both of our equations. So in our rip-off rentals, I have y equals 25 times the number of days, which is 2, plus 50 cents for the 10 miles we're going to go. Okay, so I'm going to get 50 right here plus 5. Give me $55 from Ripoff Rentals to go basically 10 miles. So that's the one option. Second person, which is your teacher, is going the same distance now. You're still doing 2 days, 10 miles. But in their equation, they don't care how many days it takes you. They just want you to go. They're going to charge you based on the miles that you go. So we said 3 cents times 2 raised to the how many miles you go, 10 miles, minus 1. So this is really 0.03 times 2 raised to the 9th power. So if I type that into my calculator, get this guy going here. So I'm going to take 0.03 times 2 raised to the 9th. It's going to give me only $15.36. That's way better. So for the first option, I'm just going for 10 miles. I want to go with my teacher's car. Okay? So what you're going to do for the next two, you're going to plug in these values. Instead of 2 days and 10 miles, you'll plug in 2 days and 20 miles. You'll plug in 2 days and 100 miles. So you can double check which one you would rather go. But you can think about this. Think about the type of equations that they are. The Ripoff Rentals we said was linear, so it's constantly growing at the same rate. Think about what that line would look like. Okay, so we think about what the line would look like. Now, you can actually find these values, and I'm not going to do that for you, because you can plug them in. So that's the Ripoff Rentals. Now, if you think about the other person, okay, the teacher, if you're starting here, it's exponential. It's going to go up and up and up faster and faster. So right now, with only 10 days, we are cheaper down here than the Ripoff Rentals, but eventually you're going to be up here if you're using your teacher's thing. You're going to go, it's going to be faster and faster, a quicker price to rise rather than Ripoff Rentals. So you're going to go ahead and plug these other values into the two equations and determine where would you rather rent from based on your mile trip.